We are going on with grade 10 exponents, and in this video we'll deal with 3 examples that work with negative exponents. So let us look at our first example. Here we have 5ab to the power of minus 3 multiplied with a fifth a to the power of negative 6b. And as I explained before, we do not look at the variables yet, we simply work with the coefficients. So if I say 5 times 1/5, that will be equal to 1, because this is 5 over 1 times 1 over 5, which becomes 1. Now we can work with the exponents. So I have a to the power of 1 and a to the power of minus 6. And because we are multiplying, we'll add those together. So it'll be 1 plus minus 6. Then we take the exponents of b and add them together. So it's b to the power of minus 3 plus 1. So remember, if there's not an exponent, that exponent is 1. And if I simplify, I can drop the 1. So I don't have to write the 1. And I'll have a to the power of 1 plus minus 6, which is the same as saying 1 minus 6. And therefore it's a to the power of minus 5. B to the power of minus 3 plus 1, so that's b to the power of negative 2. Now in algebra, our practice is to leave our answers in positive exponents. And what we have learned before, if I have anything to a negative value, I can rewrite it as 1 over a to the power of n. So I can rewrite our answer as 1 over a to the power of 5b squared. So I move both the a and the b with its exponents below 1. And now my answer is complete because my answer is in positive exponents. Let us look at our second example. So here we have 2a in brackets raised to the power of minus 2. And below the bracket we have 2a to the power of negative 2. Now notice there's a slight difference. In the numerator, everything is raised to the power of negative 2. But in the denominator, only a is raised to the power of negative 2. So let us simplify this. If I apply the law of exponents to remove the brackets, I'll multiply the exponent of 2 and the exponent of a, which is 1, with negative 2. So that becomes 2 to the power of negative 2, a to the power of negative 2, because I have 1 multiplied with negative 2, and that becomes negative 2, and a to the power of 1 multiplied with negative 2, and that becomes negative 2. That's how we remove the brackets. In the denominator, we have 2a to the power of negative 2. Now I notice I have 2 sets of a to the power of negative 2, so they can cancel out. So I'm left with 2 to the power of negative 2 over 2. And if you would like, you can move this negative exponent with its base to the bottom of the fraction. So that becomes 1 over 2 times 2 to the power of 2. And if I multiply out, that becomes 1 over 8. Because 2 times 2 squared is 8. So sometimes we don't need to apply the law of exponents where we subtract exponents from one another. Sometimes they do cancel out, and we can simplify by simply moving the negative exponents around. Let's go on to our final example for this video. So here we have x over y raised to the power of minus 1 times y over x raised to the power of 2. Now, there are various ways that you can deal with this. What I would like to do in the first term, I'm going to flip it upside down, and that will change the exponent of negative 1 to plus 1. So when you take the reciprocal of a fraction, and it's in brackets, then the negative exponent will become a positive exponent. Next, I can multiply the 2 into each of the exponents of y and x. So this becomes y to the power of 2 over x to the power of 2. And because we have our first set raised to the power of 1, we simply can say that that is y over x. Now I can multiply y to the power of 1 with y squared. So if I have y to the power of 1 times y squared, that will become y to the power of 1 plus 2, which is equals to y cubed. Next, in the denominator, I can multiply x to the power of 1 with x squared, which is x times x squared. And because the bases are the same, we can add the exponents together, and that also becomes x cubed. So we have y cubed over x cubed as our final answer.